11.5 is the last section of this chapter. It's the binomial theorem with examples. You should have watched the preliminaries first before we start on this. So what we're going to do is expand these two binomials, then we'll do some from the books. We're also going to find particular coefficients in a binomial expansion or a particular term. The term would include the variables that go with the coefficient. So the first one we're going to do is x. We're going to use the binomial theorem to expand x plus 2 to the fifth. Now I'm going to try to write small, but basically this equals, and the way you're going to write it is you're going to use 5, 0, x to the fifth, and it's going to be times 2 to the 0. So then we're going to do plus 5, 1, and then you're going to go down on your x's. So this is x to the fourth times 2 to the first plus 5, 2, x, go down, 3, 2 squared. So these two numbers should always add up to this number here. All right? Plus, I'm going to go down here, 5, 3. X, go down, so we were at 3, we're going to 2, and 2 cubed, plus 5, 4, x to the first, 2 to the fourth, plus 5, 5, x to the 0, and 2 to the fifth. Then after this, you have to clean it up. Now, first of all, we already know that this equals 1, and 2 to the 0 equals 1. So we just have x to the fifth. You also know that this just equals 5. So you have to multiply 2 times 5, and you get 10. And multiply x to the fourth. Plus, this is really 5 factorial over 2 factorial times 3 factorial, which equals 5 times 4 over 2, because the 3 times 3 let me write it, times 3 factorial times 3 factorial. Well, these cross out. And then 2 goes into 4 2 times, so 2 times 5 is 10. So basically this equals 10, and 10 times 4 is 40, x cubed, plus these two are basically the same, because you're just reversing the order here. So we're going to get 40, it's actually not, it's going to be, this is going to equal 10 times 8, which is 80, x squared, plus this equals 5, we know that. I'm not even using a calculator. 2 to the fourth is 16, times 5 is 80, to the x. We know this equals 1, so we get plus 32. So I'll put it here, plus 32. And x to the 0 is just 1. Okay, and I don't know what I did here. Let's look at this again. This is just x. There, okay, and that's it. So this here, this was to the fifth, equals that. Now on your test, I'm only going to give you 5 or less. And so if I give you less, like if I give you to the fourth power to the third, you'll have bigger numbers inside in here. All right, so let's do another one. We're going to use 2y minus 3 to the fourth. We're going to expand that. So I'm going to try to write smaller. So I'm going to write 4, 0, and that's going to be 2y to the fourth, and negative 3 to the 0. This is your A, and this is your B. Plus 4, 1. So that's 2y, and you go down 1. We started at 4, so you're going down 1 to cube, or 3. And negative 3 to the 0. Plus 4, 2, 2y squared. I knew I didn't have room. Times negative 3 to the first power. Plus 4, 3. So we're going up 1 here. We keep the 4 the same. This is going to be 2y to the first times negative 3 cubed. Again, all these numbers here should add up to 4, which I can just see here it doesn't. So I'm going to put a 1 here. Okay, now go to 4, 4, which is 2y to the 0, negative 3 to the fourth. All right. Now, we already know that 4, 0 is 1. Negative 3 to the 0 is 1. In fact, you don't even have to write that. I just do it to show the pattern. So 2 to the fourth is 16. Y to the fourth. Okay. Plus. And we're going to have a negative here. So this equals 4. So I'm just going to write this whole thing out. We're going to have 4 times 8y cubed times negative 3. All right, so all this is going to equal 96. I'll do that later. All right, plus this equals 6. And you can, I just know this from Pascal's triangle basically, but that's 4 times 3 over 2, which is going to give you 6. So this is 6 times 2y squared. Let me just write that out. 2y squared is really going to be 4y squared times negative 3 squared, which is going to be 9. All right? Plus, this equals 4 again. So we have 4 times 2y times negative 27. This equals 1. This equals 1. And so we're just adding what? 81. Now when you write this whole thing out, you're going to get 16y to the fourth minus 96y cubed plus 216y squared minus 216y plus 81, which equals that. And you notice if you have a negative here, this is going to alternate from negative to positive because of your powers being odd and even. Okay, so that's how you expand a binomial. Okay, to find a particular coefficient, we're going to find x. We want to find the quotient that goes with y to the 8th. In the expansion of 2y plus 3 to the 10th. Oh, Lord. So that's going to be a long time coming, right? So let's get started on this. We know that it's going to be 10, 0, and that's going to be 2y to the 10th and 3 to the 0. Then you're going to have plus 10, 1 2y to the ninth, 3 to the first. So if you notice, what we really want is y to the eighth. Okay, so the next one we're coming to is the 8. So we're going to get plus 10 2, sorry, let me put the plus 10 2 here, plus 10 2, 2y to the eighth, and then 3 to the second, because the second should match this number. All right, so just notice that the third term here, so this is the first term, second term, I rewrote that, and this is the third term. There's where your y to the eighth is going to be. So we could basically stop here and just handle this. We know that this here is 10 factorial over 2 factorial times 8 factorial, which equals 10 times 9 times 8 factorial over 2 times 8 factorial. So that cancels. 2 goes into 10 5, so we get 45 times 2 to the 8th. What does that equal? Oh, Lord, 2 to the 8th. 2 to the 7th is 128. So 2 to the 128 times 2 would be 16, 1. So that's 4 or 5. And then we get 2. So 45 times 256 times 9. And this, and of course you can use a calculator. I just don't have one handy right now. So basically we get 100,003,680. That is your coefficient. Okay? Now if they asked you for the term, the third term, so this would be the third term, you would write 100,003,680 y to the eighth. So if they're asking for the coefficient, that's all they want. If they ask for the term, that's what it would be. All right. Now notice, we go back to the previous video. When it was to the fourth power, we have 5 terms. 1, 2, 3, 4, 5. Here they are. 1, 2, 3, 4, 5. So we always have one more term than what's here. So let's go and do a term now. So if we're going to expand we want to find the 6th term. In the expansion of x plus 2 to the 9th. Now, you can write it all out. And what I tend to do is write it out like this. So the book does it another way, but I'm going to just show you what it would be. You know you're starting with what? It's 9, 0. Then we have 9, 1. Then we're going to have 9 what? 2. We're going to have 9, 3. We're going to have 9, 4. And 9, 5. Now, so the 6th term, this is 1, 2, 3, 4, 5, 6. This is going to be the lead. So all I'm going to do is write 9, 5. We know the 5 goes with the B part. So that's going to be 2 to the 5th. And X goes with the part that adds up to 5 plus 4 is 9. So then you have to take care of this, and you're going to get 9 factorial over 5 factorial times 4 factorial, and that's going to give you times x to the 4th times 32, and go ahead and use your calculator if you want, but you're going to get 4,036 32x to the 4th. Okay? So that's how I kind of do it so I don't mess up. The 6th term, the bottom is going to be 1 less because we're starting with 0. So let's do a couple more of those until the minutes run out. All right, so we want to find, because you have plenty of time to practice this, we want to have the 5th term, of the expansion of x plus 3 to the 7th. Excuse me. This is your 35 on page 869. So what I'm going to do is I'm just going to write out 5 of these. So that's 1, 2, 3, 4, 5. So this number is always going to be 1 less than the 5th term. So that's what I'm going to write. I'm going to write 7, 4. And then this is going to be x and times 3. And this number always goes here. So this is going to have to be 3 because 3 plus 4 is 7. And then 7 fours, what's that going to be? For, I'm not going to do this one in my head. So this number is 35. Where is it? 35. Oh, is it here? Yeah. Well, they don't do it either. So basically, we're getting, this is basically 7 times 6 times 5 times 4 factorial over 4 factorial times 5 factorial. No, not 5 factorial, but 3 factorial. So 3 factorial is really 3 times what? 2. Again, this right here is 7 factorial over 4 factorial times what? 3 factorial. So the 4 factorials cancel. This is going to cancel, so you get 35 times 81 x to the 3rd. Use your calculator, and that equals 2835 x cubed. Okay? So that's how I do it. You want to do another one? Let's do one that's a little harder. Let's do 37, and that'll be it. So 37 would be, we want the 3rd term, well, it might not be so bad, 3rd term of 3x minus 2 to the 9th. So I'm just going to write 90, 91, and of course you don't have to do this all the time because now you've got the idea. This number should be 1 less than the term part. So we're going to have 9, 2, the negative 2 goes squared, goes with the 2 part. This is the b part. And the 3x is going to go to the 7. All right? And then when you work all this out, this is 9 factorial over 7 factorial times 2 factorial, which is 9 times 8 times 7 factorial over 7 factorial 2 factorial. 2 factorial is just 2 because 2 times 1. These cancel. 2 goes into 8 4 times, so that's 36. I have no idea what 3 to the 7th is, so you just have to use the calculator. So this is going to be 3 to the 7th times 4 x to the 7th. And this all equals, 300,014 and 928 x to the 7th. So it's pretty easy. You get to use a calculator and all's well.